Moving on, a struct is a group of related subvariables or fields. This is really a new kind of type. It's similar to classes in Java in that you can collect related information together, but structs don't have methods and everything is public. These subvariables are called fields, and struct variables are declared using the struct keyword. So this declares that there is a struct called vertex. It contains 3 subfields or 3 attributes. Maybe you're used to terminology from Java. So it has 2 double precision numbers, x and y, and then a Boolean value called visited. So this is a struct that might be useful in thinking about graph traversals, perhaps, if you've heard of those before. So here's an example of using a struct. So we declare P1 to be of type struct vertex, and you'll notice that we have to use the struct keyword again here when we're declaring the variable of type struct vertex. And now we can access the members of the variable or the struct using the dot operator, just like you would in Java. And so here's an example of a function that takes 2 structs, 2 vertices, and calculates the distance between them. And it does so using this formula here, where it takes the difference between the x component squared and y component squared and takes the square root. So basically it's the distance formula calculated using members of the vertex field. Now, it can be a little annoying to write out struct vertex every time, and so this is where we use a typedef to shorten things. So by convention, we're going to create a typedef name for all of our struct types, and so instead of having to say struct vertex everywhere, we're going to create a typedef, which is sort of the name of the struct with an underscore t. So instead of having to say struct vertex, we'll just say vertex t. This is, clearly more concise and readable. And for the projects, we will be providing these to you, so you don't have to write these yourself. These will be in the headers. And we do that simply by surrounding the struct definition with a typedef definition. So basically, we're saying take all of this in here, this whole struct definition, and we're going to call that vertex t. And so that cleans up the code a lot, because now we can just say vertex t instead of struct vertex everywhere in the code. Under the hood, these fields are stored mostly contiguously in memory. We'll see an exception to that in just a second. But every field is going to have a fixed offset from the beginning of the struct. So here is a little diagram indicating, so this is all the memory that is allocated for variable P1, which is a vertex. So it's going to have 3 members, so this memory is going to be divided up into 3 chunks. So the first chunk is allocated for this double precision number x. Since we know that double precision numbers are 8 bytes, that means that the first 8 bytes in this variable are allocated for that field x. Which means that the next one has to begin at least offset 8. So assuming that it does begin at offset 8, the next 8 bytes will be the y field. And then finally, the Boolean, which is 1 byte long, can begin at offset 16. And so this is what the struct would look like in memory after executing this code right here.